Okay, so in this video, I'd like to discuss with you finding the domain of expressions that contain square roots and fractions, or one or the other. So some combination or even just by themselves. So let's look at the first example. So the first thing, that if we're only talking about really square roots and fractions or some combination, then we really only have two domain restrictions. We know that if we have a square root, that what's under the square root, the radicand, has to be greater than or equal to 0. Because if we try and take something, the square root of something that is less than 0, some quantity less than 0, then we're going to get an imaginary number. Okay, so the second thing that I'm always going to check for is if it is a fraction, I know that the denominator cannot be equal to 0. So this is the process every single time. So I look at this equation. Okay, does it contain a radical? And it absolutely does. So the radicand, the value under the radical, that quantity, x plus 1, has to be greater than or equal to 0. So I'm going to subtract 1, and I get x has to be greater than or equal to negative 1. Now this makes sense, because if I plug negative 1 back in, that makes it 0. Negative 1 plus 1 is 0, and the square root of 0 is 0. But if I try and go to the left of negative 2, so less than negative, if I try and use negative 2, which is less than negative 1, I get negative 2 plus 1 is negative 1. And we know we cannot take the square root of a negative in the real number system. Okay, so I already know that no matter what else is true about this expression, that x has to be greater than or equal to negative 1. So then the next thing I'm going to check is if the problem has a denominator, that denominator cannot be equal to 0. This one absolutely has a denominator, so we have x plus 1 cannot equal 0. So I'm going to square both sides, and I get x plus 1 cannot be 0. And I get x cannot be equal to negative 1. Now we know this. We can take the square root of 0. We just can't have 0 in the denominator, and that's what this tells me is going to happen. Negative 1 plus 1 is 0, and the square root of 0 is 0, and we just can't have 0 in the denominator. So I'm going to say that my domain then is negative 1 not included up to positive infinity. Now remember, you can do it in one step by simply stating that the radicand as a whole has to be greater than 0 but not equal to. Okay? So the next problem, again, I have that if I have a square root, that radicand has to be greater than or equal to 0. So I have 2x plus 1 has to be greater than or equal to 0. So I have 2x is greater than or equal to negative 1 divided by 2. So x has to be greater than or equal to negative 1/2. Now I have a denominator, and we can set this equal to 0, but that's just 5 cannot equal 0. Well, we already know that. 5 is never equal to 0. 5 is equal to 5. So my only thing that pertains to my x values is that radical. And it says that at negative 1/2, it's going to be 0. And then everything greater than negative 1/2 is going to give me some positive argument that I can absolutely take the square root of. So my domain is going to be negative 1/2 included to positive infinity. Okay? So the next one, we absolutely have a denominator that cannot be equal to 0, and we have a radicand that has to be greater than or equal to 0. Again, notice that the radical is the entire denominator, so we can do this in one step because we already know what makes the radicand 0, what makes the radical 0 is not going to be able to be included because that's going to be negative 2 divided by 0. So my radicand is 3x plus 2 greater than 0, so I'm just going to solve. So I have 3x is greater than negative 2 divided by 3, and I get that x is greater than negative 2/3. Now I can check the validity of my answer. I can sub in that negative 2/3, so I have the square root. So we'll say negative 2 over the square root of 3 times negative 2 over 3 plus 2. So that's going to give me negative 2 over the square root of negative 2 plus 2, which gives me what I expected, the square root of 0. That is a no-go. We absolutely cannot do that. Okay, so we know we cannot divide by 0, so we cannot do that. So it's not included. That's why it's not included. But anything greater than negative 2 over 3 can absolutely be included. And a lot of times you want to say that 0 is discluded because it can't be in the denominator. But remember that the square root of 3 times 0 plus 2 is just the square root of 2. And that's totally allowable in the denominator. So my domain would just be negative 2/3 to positive infinity, and we're just going to disclude that negative 2/3. Okay? So in this problem, it's a little bit different because my entire radical is not my entire denominator. So I have a piece of my radical as a denominator. I mean, a piece of my denominator is a radical, but not the whole thing. So anytime I see that radical, I'm going to say that the radicand has to be greater than or equal to 0. And anytime that my denominator contains an x, cannot be equal to 0. So my radicand is easy this time. It's just x, the quantity under the radical. So x has to be greater than or equal to 0, which makes sense because in English terms, this means that x has to be positive or 0, and those are absolutely things that we can take the square root of. My denominator is the square root of x plus 1 cannot equal 0. So we have subtract 1, and I have the square root of x cannot equal negative 1. Now, oftentimes I try and stop here because this is not a logical statement. In order for my denominator to be 0, this quantity would have to be equal to negative 1. That's what this says. Okay, so the square root of x cannot be negative 1. Well, the square root of x can never be negative 1. The square root of x has to be a positive number or an imaginary number, but it can't be a negative 1. Okay, but let's just say you didn't catch that. Let's say that you went on and you solved the problem. So we have squared, squared. So x cannot be 1. So we are saying that we would have to disclude 1 on the basis that it makes my denominator 0. Well, the problem with that is it doesn't make my denominator 0. Because if I plug in, I get 12 over the square root of 1 plus 1, which is 12 over. The square root of 1 is 1. 1 plus 1 is 2. 12 over 2 is 6. It is absolutely not undefined at x equals 1. So there's no way that this is a restriction in my domain. There's no way that the denominator could ever be 0. So I don't even have to consider it. So the only thing that I have to consider is what pertains to the radical. And that's that the quantity has to be greater than or equal to 0. So my domain is 0 to positive infinity. Okay? So this is a very similar problem. So we know that we have the radicand has to be greater than or equal to 0. So x has to be greater than or equal to 0. It's the only thing under the radical. My denominator, once again, cannot be equal to 0. So I have the square root of x minus 3 is not equal to 0. So I'm going to add 3. Okay, so from here, this is a logical statement. The square root of something could be 3. That is an absolutely logical statement. So I'm going to continue squared, squared. So I have x cannot be equal to 9. Now again, check the validity of your statement. Does 9 make my denominator 0? Well, the square root of 9 is 3, and 3 minus 3 is 0. So this absolutely cannot be a part of my domain. Okay, so I have to consider both of these things. So this says for my radical that I can take the square root of anything 0 or bigger. But this says, well, you can't make the denominator 0, so you can do that. You can do this part, x greater than or equal to 0, you just can't be 9. Okay, so my domain would then be 0 to 9, and we're going to disclude 9 to positive infinity. Okay, so same thing, radicand, greater than or equal to 0, so x has to be greater than or equal to 0. So then my denominator also cannot equal 0, so 5 minus the square root of x cannot be 0. So I'm going to add the square root of x to both sides. And I get 5 cannot equal the square root of x. So 5 is a positive number, a completely legitimate solution to a square root problem. So I'm going to square both sides. 25 cannot be equal to x. So again, this is something we can check the validity of. Does 25 make my denominator 0? Well, the square root of 25 is 5, and 5 minus 5 is 0. So it absolutely is true. So for my radicand, x has to be 0 or larger. For my denominator, it can't be 25. So my domain overall is 0 to 25, discluding 25 to positive infinity. Okay? So again, I have a square root, so my radicand has to be greater than or equal to 0. So I have x plus the square root of 8 greater than or equal to Nope, sorry, I was thinking denominator. My radicand is what's under my radical, so that's x greater than or equal to 0. My denominator cannot be 0, so I have 8 plus the square root of x cannot be equal to 0. So I'm going to subtract 8. So I have the square root of x cannot be equal to negative 8. Again, this is an illogical statement. Okay, for this to be 0, this quantity would have to be negative 8. That's what this says. That can't happen. The square root of a number cannot be a negative. Okay, so let's say you didn't catch it. Squared, squared. So I have x cannot be 64. Does 64 make my denominator 0? Of course not. The square root of 64 is 8, and 8 plus 8 is 16. So this is not even a possible problem that we're going to encounter because the denominator can't be 0. It's mathematically impossible. So the only thing that we have to consider then is what satisfies the radical, which is going to be 0 to positive infinity. Okay? So here we have that the radicand, again, has to be greater than or equal to 0. So 3x has to be greater than or equal to 0. So we're going to solve so x has to be greater than or equal to 0. Again, the denominator can't be 0, but there's no x in the denominator. But that's easy enough to identify because 12 can never be 0. 12 is 12. So our domain, once again, 0 to positive infinity. I don't even have a radical in this problem, so I don't even have to do the radicand part. I'm going to do just the denominator because the denominator can never be 0. So x squared minus 16 cannot be equal to 0. So you can do this one of two ways. You can factor x plus 4, x minus 4 cannot be equal to 0. Or you can use square root property and add 16. And we get x squared is equal to 16. And square root both sides. We get x cannot be plus or minus 4. And this would be x cannot be 4 and x cannot be negative 4. Okay? So you get the same solution either way. So it says it can be anything in the real number system except negative 4 and positive 4. So anything means I start with negative infinity up to negative 4, union, negative 4 to 4, union 4 to positive infinity. Okay? So here again, we have the denominator cannot be 0. The radicand has to be greater than or equal to 0. So x cannot be 0. That's the only thing in the denominator. The radicand is 1 over x has to be greater than 0. Now this takes a little bit of logic because if you try and solve and multiply by x on both sides, your x disappears because x times 0 is 0. So let's think about this. 1 divided by what type of number is going to give me something greater than 0? Okay, well, if I divide by a negative number, so negative numbers, so a negative number would be where x is less than 0. 1 divided by a negative number is going to be a negative. So my other option is where x is equal to 0. Well, in this scenario, x can't be 0 because you can't divide by 0. The only other type of numbers are positive, where x is greater than 0. Well, a positive divided by a positive is a positive, which is greater than 0. So this says that x is everything greater than 0, and this says, well, it can't be 0. So my domain is 0 to positive infinity. Okay? So my radicand has to be greater than or equal to 0. Again, my denominator cannot be equal to 0. Notice that my entire denominator is my radical, so I can solve this in one step by saying the radicand can be everything. The radicand can be anything that makes it positive. It just can't be 0 because my denominator can't be 0. So I have 2x minus 1 is greater than 0, and I'm just going to solve. So I have 2x is greater than 1, divide by 2, and x is greater than positive 1/2. Okay? So to write that, we're going to do parenthesis to show that we're not included, 1/2 to positive infinity. Okay? Okay, so we're going to do the same thing. I have a square root and I have a fraction, so I'm going to say that my radicand has to be greater than or equal to 0, and my denominator cannot be equal to 0. So my radicand is 2x plus 6, has to be greater than or equal to 0, so I'm going to solve. So I have 2x plus 6, 2x is greater than or equal to negative 6. Divide by 2, x is greater than or equal to negative 3. So that's my first condition. No matter what else, x has to be greater than or equal to negative 3. So my denominator can't be 0, so 3x cannot be equal to 0. So x cannot be equal to 0. So 0 is greater than negative 3, so I have to take that into consideration. So I have negative 3 to 0 union 0 to positive infinity. Okay? So again, same thing. I have a square root, so my radicand has to be greater than or equal to 0. I have a denominator that contains x, so my denominator cannot be equal to 0. So my radicand, 3x minus 6, is greater than or equal to 0. I'm going to solve. So I have 3x is greater than or equal to 6. So x is greater than or equal to 2. So my denominator can't be 0, so x minus 7 cannot be equal to 0. Now add 7 to both sides, and I get that x cannot be equal to 7. So this first part, in order to sub an x into the radical, it has to be 2 or larger. Well, that's fine with the denominator, except it's 7. So I'm going to have to disclude 7. So I'm going to do 2 to 7 union 7 to positive infinity. Okay? So again, I have that combination. Now, we don't care about the numerator. The numerator can be whatever it wants. It can be a positive, a negative, a 0, a fraction, a decimal, anything. It's the denominator we have to worry about, and that radical, right? So that radicand has to be greater than or equal to 0, and my denominator cannot be equal to 0. Now, notice that the radical is not the entire denominator, so we cannot combine these two things. So the radicand, x is greater than or equal to 0. So no matter what else happens, x has to be 0 or larger, okay? So the denominator says, well, the square root of x minus 6 can't be 0, so I'm going to solve. So the square root of x cannot be equal to 6, so I'm going to square both sides. So x cannot be equal to 36. So let's check the validity of our statement. If I sub 36 in, does it make the denominator 0? Well, the square root of 36 is 6, and 6 minus 6 is 0. So that's absolutely true. So I have the denominator is going to start with 0 because we've already said, based on our radical, our square root, that we can't go less than 0. So 0 to 36 union 36 to positive infinity. Okay? So no radical this time, just a denominator that cannot be equal to 0. So sometimes things just don't work out nice and pretty, and that's okay. That doesn't make it any less of a correct answer. So x squared cannot be equal to 5. We're going to square root both sides, so I get that x cannot be equal to plus or minus the square root of 5. So it can be anything else except the plus or minus the square root of 5. So I have the domain. Anything else means negative infinity, negative square root of 5, union, negative square root of 5 to square root of 5, union, square root of 5 to positive infinity. Okay? So here we go again. The radicand, because I have a square root, has to be greater than or equal to 0, and my denominator cannot be equal to 0. So my radicand, 2x minus 8, greater than or equal to 0. I'm going to solve for x. So I have 2x is greater than or equal to 8. So x is greater than or equal to 4. Okay? So we need to figure out what makes our denominator 0. So I have x minus 3 cannot equal 0. Add 3. So I have x cannot be equal to 3. Well, that's convenient because my radical says I can't even start until I get to 4. So I don't have to disclude 3 because it's already discluded because my domain doesn't even start until I get to 4. And the last problem. Same scenarios. So my radicand, because I have a square root, has to be greater than or equal to 0. My denominator cannot be equal to 0. So my radicand, 3 minus x is greater than or equal to 0. I'm going to solve negative 3. So I have negative x is greater than or equal to negative 3. Divide by negative 1. So don't forget that when you divide by a negative that you have to flip the sign. So I have x is less than or equal to positive 3. Now this makes sense because when you plug in a negative, you're going to get a positive here, right? So 3 minus a negative 1 would be a positive 4. Okay? My denominator, x plus 7 cannot be equal to 0. Subtract, and I get x cannot be negative 7. So everything less than positive 3 includes negative 7. So I can't be everything less because I have to exclude negative 7. So my domain is going to be negative infinity up to negative 7, union negative 7 to positive 3.